Hello, everyone. I'm Chris Weed from the National Trust for Canada. Welcome to this very special webinar, CARE Tool, Quantifying the Carbon Savings of Reuse. We at the Heritage Trust are so pleased to be presenting this webinar today jointly with CAHP, the Canadian Association of Heritage Professionals. CAHP is a national membership-based organization that serves qualified heritage professionals in the public, private, and not-for-profit sectors. Great to be working with them. I want to begin by recognizing all of the Indigenous lands all of us today are living and working on. I'm coming to you from Ottawa, the traditional unceded territory of the Algonquin Anishinaabe people. We know that all of you are joining us from other parts of Canada and beyond, and encourage you to join us in reflecting on the histories, languages, and cultures of Métis, First Nations, and Inuit communities whose presence continues to enrich our shared heritage. Just some words off the bat on functionality. To ask questions, please use the Q&A button at the bottom of your screen, and you're welcome to, and that'll get the questions to the presenters. You're also welcome to use the chat function to connect with webinar attendees, but please do use the Q&A function to direct questions to presenters. And please note, we always get this question. We will have a recording available shortly afterwards, and it'll be available to you on the National Trust and CAHP YouTube channels. So just wanting to, next slide, please. Just wanting to say a few words about the National Trust for Canada. These webinars really are an important part of the work we do to build the heritage community in Canada. Through sessions like this and through our national conference and programs like Launchpad, we work to empower people to use heritage to create livable communities, to reflect the diversity of Canada and tell its many stories, and to contribute to climate action. And similarly, CAHP does that kind of work with its CAHP Workroom, which we are also bringing to you this as well today. So here are some of the different ways you can connect with the National Trust and keep in touch via social media. Next slide, please. We are so thrilled to have this walkthrough and discussion of the recently launched CARE tool, the Carbon Avoided Retrofit Estimator. Truly, the importance of this tool shouldn't be underestimated. CARE represents the first tool to allow the operational carbon and emitted carbon of buildings to be looked at holistically. It really is the first tool that lets us clearly see the reuse potential of existing buildings and heritage buildings from a whole carbon perspective. So for the order of events today, we'll first hear from Erin McDade, who is in Bellingham, Washington. Erin leads Architecture 2030's public policy and embodied carbon initiatives, focusing in particular on developing data-driven solutions for building sector decarbonization. Erin is one of the co-creators of the CARE tool, along with Laurie Ferriss, and who we'll also hear from today, and Larry Strain. Larry sadly couldn't be with us today. So in terms of running order, Erin is going to provide a background on the connection between buildings and carbon emissions and how the CARE tool can help better help us understand those connections. Then she'll introduce Laurie Ferriss, who will walk us through how this tool can be put into practice for both individual buildings and larger groups of buildings on a campus, for instance. Erin will then come back and describe how you can use the tool for the places you care about. And finally, we'll close with a good solid round of question and answer and discussion. This will include insights from our two CAHP members who are on the call today, who have explored the tool in depth, Emad Ghattas from Toronto and Austin Parsons from Halifax. So we'll bring them in a little bit later. And so with that, I think I will turn it over to Erin McDade.
Thank you so much, Chris. Let me get the slides up here. All right, can everyone see my screen? Great. All right, well, first of all, thank you so much for having us. We are thrilled to be able to be presenting to you today and thrilled to be able to be making even greater connections to the heritage community specifically. We're having a bit of conversation about how critical the heritage community is in the existing building sector in particular before this webinar started. And I'm excited to continue that conversation and excited to see so many of you on the webinar. So let me get started. As Chris said, before we get into looking at the C.A.R.E tool and some case studies, we want to talk about why we're here in the first place from a climate perspective, why we're even having this conversation about existing buildings. So for those of you not following along on the nitty-gritty of our kind of climate change progression, the Intergovernmental Panel on Climate Change releases periodic reports showing our status, making projections about future emissions, et cetera. And the most recent report shows that we have about 340 to 400 gigaton carbon budget globally that we can emit if we want to keep within that 1.5 degrees C target that the Paris Agreement set and that most of the world agreed to. And so what this looks like, typically, we're emitting about 40 gigatons of carbon a year. This chart starts in 2020, but that has not changed dramatically in the last 3 years, even despite COVID. And what we can see is that if we were to peak emissions ASAP and zero those emissions out by 2040, then we would stay right within that budget. So just, barely squeaking under. And what that really looks like and what Architecture 2030 is calling for is a 50 to 65% reduction in all global emissions by 2030. So that includes the building sector, of course, but everything else, and then zeroing out by 2040, like I said. So partly I present all this because for me, when I'm doing my work and when I'm, working on C.A.R.E particularly, I'm always keeping in the back of my mind this 0 by 2040 year. So our 0 year is 2040 and everything I'm doing is working to align with that. So diving a little bit into existing buildings specifically, there is a truism in the architecture and design world, and I'm assuming in the heritage world as well, that the greenest building is one that's already built. And if we do a quick look at what a typical new building's carbon footprint is, we can get a sense of why. So when we're constructing a building, there are a lot of emissions, of course, associated with that. There are all the emissions from the material extraction, from transporting these materials, and from actually building the building on site. We call that embodied carbon, and those emissions are in the atmosphere before the building is even occupied and operated, and they stay up there forever. And so in this case, this average global new building has a decent amount of embodied carbon emissions. And again, once they're up there, they're always up there. And then starting on day one of a building's occupation, there are operational emissions, and those operational emissions start smaller and they build up cumulatively. And similarly, once they're up there, they're up there. Of course, with operational emissions, we can always retrofit and we can reduce those. With embodied carbon, no chance. So if we're looking at this typical new building and we're drawing a line in the sand at our 0 year of 2040, we see that even though those operational carbon emissions are rising and cumulative in this example, we still have almost 60% of the total operational emissions pie for this building being embodied carbon. And when we when we reuse existing buildings, this green piece, this embodied carbon emissions is significantly reduced, which is what we'll talk about in more detail with the C.A.R.E tool. But we can see because of this, that if we are able to save the majority of these green emissions, and we're able to curve down our operational emissions, then of course, reusing an existing building in this case is going to be smarter. But since we do have those blue emissions, those operational emissions that we haven't always gotten down to zero, what we see from a bigger picture context is that in urban environments, especially urban environments across the world with a significantly developed and older building stock, existing buildings represent the majority of total emissions for those entire urban environments and cities. And you can see examples of that across the world from a large variety of cities in different climate zones and regions. So obviously addressing existing buildings is pretty critical. And if we scale that all the way up to a global perspective, what all of the estimates show us is that by 2030, 2/3 of the buildings that will exist in 2040, sorry, I think I said 2030, in 2040, will be buildings that exist today. So what that means is that most of the buildings that we see when we look around today are still going to be here in our 0 year. And if we have not touched those in terms of operational emissions reductions, they're still going to be emitting a significant amount of carbon, arguably the majority of the carbon in the world. And so we will never achieve climate targets if we don't reduce those existing building operational emissions. So I would posit that instead of the greenest building being one that's already built, the greenest building is one that's been retrofitted. And that is really at a high level, the genesis of the C.A.R.E tool. And Chris already did a great job of a high level intro of the C.A.R.E team, but I just want to quickly do a little introduction, especially of our team member, Larry Strain, who can't be here today. He is the founding principal at Siegel Strain Architects. They're a firm out of the Bay Area in California, and they do a lot of reuse work. And then, of course, my colleague, Lori Ferriss, who you will hear from later. She's the principal director of sustainability at Goody Clancy, which is out of Boston, and they do a lot of preservation, especially historic preservation work. So she will be a fantastic person to have this conversation with today. And then myself. And Larry was really the one who started the C.A.R.E tool back in 2018-19. He was approached by the Office of the President for the entire UC campus system, University of California campus system. And his colleague there said, what tool do I need to use for us to be able to look at all of the buildings we have on campus and decide, does it make more sense to reuse them? And Larry thought about it and said, wow, I don't think that tool exists. There are plenty of tools to look at material emissions. There are plenty of tools to do, energy modeling and look at operational emissions of buildings. There are whole building life cycle assessment tools that look at embodied carbon, but there are no tools that just take a snapshot of the entire carbon picture over time of a building and say, from a climate perspective, what is the smart decision to make here? And so Larry started a rudimentary Excel calculator. Some of you may have been on a webinar a couple of years later with the National Trust in the US where Lori and Larry presented that rudimentary Excel calculator that we had expanded upon. And a few years later, and thanks to significant support from a lot of collaborators, funders, and the three of us, the C.A.R.E team down here, we've been able to turn that calculator into what the C.A.R.E tool is now today, which we are very excited about. So briefly, before I talk a little bit about what the C.A.R.E tool looks like and how it works, I want to give some clarifications on what the C.A.R.E tool does, what its goals are, and also what it doesn't do, which is pretty important too when considering how and when to use it. So like I said, it evaluates the total carbon emissions and impact potential of existing building reuse as compared to replacement new construction. What it does not do is detailed energy modeling, whole building life cycle assessment, or unlike some other tools out there that some of you may be familiar with, it doesn't allow a lot of detailed back-end user overrides of the data. There are reasons behind that. We can talk about that. But importantly, we've designed the tool to output as many default assumptions as possible so that you need to know as minimal information as possible to still be able to use the tool and start making some decisions. But those default options can all be overrode in case there is more detailed information. And as you will hopefully see when we actually dive into the tool here, our goal for this tool was to make it be very broadly accessible so that you do not need a very in-depth information set, not only about buildings that you may be considering preserving or tearing down, but really even about the building sector in general. So hopefully this tool is usable for public officials, planners, heritage officers, educators, real estate developers, et cetera, as well as, of course, people within the building sector, design professionals, building owners, et cetera. And so a quick overview of what kind of information the tool asks you to input in order to get the outputs. You'll see all of this in much more detail as Lori and I both go through it. But once you get to the tool, there are 4 tabs of information that you fill out and click through. The first one asks general, pretty high level information about climate and location and some electricity grid emissions considerations. Then the existing building tab asks for a few details about the building that you are currently looking at and considering either renovating or replacing with new construction. Then the last two tabs are tabs where we're getting into the hypotheticals. So if you do decide to reuse this existing building, there are some questions that the tool wants you to answer about if the size or use is going to be changing. There are some operational energy and carbon questions that the tool will ask, although again, this is a place where a lot of default assumptions will already be populated. So if you don't know the answers to these questions, that's totally fine. The tool will go forward anyway. And then questions that will really affect the embodied emissions for the project about the different systems and elements of the existing building and how those might be affected by your upgrade. And then similarly, you get to the new building tab, considerations about operational energy and emissions for if you replace this new building, and a couple even higher level questions about what that new building might look like from a structural perspective that affect embodied carbon. And I am not going to go through the details right this moment of all of what that looks like and how those inputs work, because we are going to get some case study examples of that from Lori. And then as Chris said, I'm actually going to do a quick live demo so you can all get a sense of how easy and fast it is to get some results out of this. But so you're prepared for what the results should look like. Once you have entered enough information on those 4 tabs, there are a couple of charts that will appear. There's also a data table that will show all the results. And the first chart, this bar chart, is a snapshot in time of the total embodied and operational emissions for each of those 3 scenarios. The do nothing scenario, where you just leave that existing building and don't touch it. The reuse and addition scenario, or the new construction, the new replacement scenario. And I think an important part of this, and at least for me when building the whole CARE tool, is that on the very first tab, we'll see it, you get to enter how many years you want this the tool to look at for your building. And so I talked again about that 0 year 2040 and doing everything through that lens. So when I'm running through the CARE tool, I'm almost always at this point inputting 17 years there, because I want to look at what this is going to look like in 2040. But of course it's dynamic, and that you can change that as you're entering information and see how the impact of more or less time impacts the distribution of these charts, which is pretty interesting. So like I said, the first bar on here is the do nothing bar, and we can see that this light blue is operational emissions, this dark blue is embodied emissions. If you don't touch the building, there are not going to be any additional embodied emissions. You've already built it. Those are already up in the atmosphere. And it'll continue to emit operational emissions for this 17-year period in this case. And then we can see for the retrofitted building, the light blue, the operational emissions are dramatically less than the do nothing building. So I can already tell that for this example, the building achieved significant energy efficiency improvements, so operational emissions reductions, but that came at a bit of an embodied carbon cost, which you can see right here. Here's the embodied penalty, if you will, for achieving those embodied emissions reductions, as well as any of the other retrofits and upgrades to the building that were necessary. And then if we look at the new building, we see that it's even better in terms of its operational performance. It didn't quite get down to 0 operational emissions. But because the entire building needed to be replaced, we couldn't save any of the structure, any of the envelope, et cetera, as we presumably did here. The embodied carbon penalty, again, for achieving this dramatic reduction in operational emissions and any other additions and changes to the building that were required, is pretty high. And so in this case, for this example, I would say, okay, seems pretty clear to me that for our 0 year, the reuse and addition is going to be our best bet. And in an ideal world, I would take this now to another tool that is more granular, and I'd say, okay, what can I do to even get this blue operational emissions box down even farther without adding too much to the embodied carbon box? And hopefully we'll get to the point where we have an optimized reuse project. And then this tool, this chart, it shows kind of just a different picture. It shows the cumulative emissions over time and how those 3 different scenarios interact with each other. So we can see that for this example right here, it takes about 6 years, a little over 6 years, for the new building to make more sense than do nothing. And it takes under 2 years for the retrofitted building to make more sense than the do nothing building. And I'm almost ready to pass this now to Lori, so you can get some insights on what this looks like in real world projects. But I know one thing that's important. We have been able to present this tool to different groups outside of the United States. And currently the tool only has data in it, particularly climate data, although the embodied carbon data is regional too, and we'll talk a bit more about that later. Only has data in it from United States data sources. That being said, there are a couple of short-term workarounds that, that I've developed so that you all do not need to wait to use the C.A.R.E tool right now. But then long-term, again, I want to be clear, we have plans to regionalize the tool as much as absolutely possible so that it actually has data from each of your individual countries. But so quickly, the first workaround is to use a comparable US zip code. So when the tool is analyzing climate data, essentially the zip code for the United States is going to tell it what the heating degree days and cooling degree days are. If you don't know what that is, it really doesn't matter too much, but that is what is going to determine all of the climate information. And so if you are able to determine a comparable zip code for your city. And so for this one, I did a little bit of Googling. There's not a great data source for this, but I did a little bit of Googling yesterday, and it told me that Chicago, Illinois is a very comparable in terms of climate city to Toronto. And so I decided to, do a C.A.R.E Toronto example here to show that. And so I put in a zip code for Chicago, Illinois. And so now the tool is going to have climate data that it thinks looks similar to Toronto, Ontario. And then the other important part for electricity grid emissions, there are a bunch of different options that are, again, fairly customized to the US context because that is what we currently have data for. But we have an option here where you can select enter your own grid decarbonization year. And what this really means is that if you are living in a region that has some sort of a policy that will require your electricity grid to decarbonize by a certain date, or perhaps you're on a campus that has a net zero goal, net zero by 2035 or 2040, you can use this to customize and say, for my region and for this context, I think my grid will achieve zero carbon by X date. And so that will help you get a clearer picture of what the emissions impacts from the electricity grid will look like for your scenario. Then the other, arguably a tiny bit more complicated but more accurate way of using the tool would be, instead of trying to do the postal code, zip code alternative, is to go right to the source. And this is what I'm talking about. Heating degree days and cooling degree days are really the climate metric that determines all of the operational emissions considerations. And so there's a website called degreedays.net. It is fairly intuitive to use. This might not be something, if you have never heard of degree days before, it might not be the best path. Might be better to just do the zip code route. But if this is something you maybe learned back in school a couple decades ago, like me, and you had to go relearn it, it's not that hard. You can go to degreedays.net. You can figure out how to generate these for your very specific weather station, and just make sure you use Fahrenheit and you can input that. And with that, last slide. This is just what the homepage looks like, but we're going to see this anyway because I'll do a demo. So with that, I'm going to pause for now, and I'm going to pass it to Lori, who will show this in real world, real project use.
All right, thanks, Erin. Yeah, so I'm going to speak first just about a single building, and then about how C.A.R.E can be applied at the portfolio scale. So looking at the single building, this is a project that we completed back in 2014. It was the conversion of a purpose-built Hillel Center from the 1950s to a campus admission center. You can see it's one of the few international style buildings in Boston, actually. It's pretty special, and it lives right at the end of a historic district. So there were, certainly heritage conservation considerations in terms of the reuse, although you can see it did involve quite a bit of a comprehensive renovation of the interior, as well as some pieces of addition on the exterior, as well as conservation of most of the facade, including that really cool wood penthouse. Next slide. So because this was a comprehensive interior renovation, we were able to make quite a bit of energy performance improvements, which included high performance glazing and insulating the walls from the interior as well as the roof. Obviously, in addition to high performance systems, which almost completely brought the building over to electricity from fossil fuels. And through all of this renovation, we were able to reuse 86% of the existing structure and enclosure while reducing the energy use by about 70%. Next slide. I'm going to walk through these quickly because Erin will show you how this works live. But essentially, as we go through these tabs, we first input that general information, where the building is. That we then define the existing building, how big it is, and its existing energy use, as well as what it's made of. Then we go through the building reuse tab, and this is the most extensive tab. And I think all of you are familiar with what it takes to reuse a building and know that there are basically an infinite number of decisions you could make about how we reuse and preserve buildings. So that's why there's so much to input here. We want to know, was there an addition? So in this case, there's a small amount of addition. We can here demonstrate that really significant energy improvement we were able to make, as well as define the scope of the intervention. So here, for example, we're reflecting there was relatively little structural work to the existing building. We did, the complete interior renewal, new systems, as well as the addition. Next slide. And lastly, we define the new construction. This is more straightforward. Essentially, how big is the building? In this case, we're showing a building kind of like apples to apples. So the same size building used for the same thing in contemporary steel concrete construction. And in this case, I've given the new building a boost, an energy performance boost of about 15%, just to kind of illustrate the difference. And because I always get that question from people that do mostly new construction, well, wouldn't it have been more efficient to just make a new building? So let's say that it was. And what we see from the results on the left are those total emissions for the demonstrated time period. In this case, I showed 15 years, which would be through the year 2030. And we can see, of course, that the reuse and retrofit was the lowest carbon option of all three. And on the right, we see those, again, the crossing lines. So we see the small amount of embodied carbon from the renovation and the larger amount of embodied carbon from a replacement building. And we see that the renovation, again, pays off after about only 2 years, which is a really good carbon payback. And we also see, again, that if we look at the light blue and dark blue lines, they don't cross by the target year here, which means that for the whole duration of the study, the renovation is going to be the lower carbon solution compared to replacement, even when the replacement is more efficient. And this is just to kind of give you a taste of what I think one of the most fun things about the tool is you can analyze the building, but then you can kind of explore some what if scenarios. So, on the left, we have the as-built condition, and in the middle, I kind of just here played around with, well, what if it was just kind of code minimum new construction, not high performance new construction? And so you can see the really dramatic impact of that. And in fact, the new building in this case is barely better than doing nothing to the historic building if you kind of built it at code minimum for that time. And on the right, we start to look at playing with greening of the grid. So especially if you can electrify the new construction, you can see how all of the bars will start to diminish as we take into account decarbonization of the electricity. And next slide. Okay, now I'm going to scale this up to a portfolio. So here we're looking at Agnes Scott College, which is outside of Atlanta, Georgia. It's a women's college founded in the late 1800s. And the campus is also part of a historic district here, the entire campus. And one thing that's really interesting about the school's approach to campus management over time is that it has really been kind of stewardship focused. And while this was not really a codified approach or anything, it was more of a philosophy that their historic infrastructure and buildings were so important to the identity of the school and really, part of the student community and loyalty and their academic success. So over time, as they've grown, they've added new buildings, but they've also repurposed all of their existing and historic buildings. They've moved them around on the campus. Oh yeah, you can keep going. Sorry, thanks, Erin. They've moved them around. So, to kind of make space for new buildings, and they've adaptively reused, but they've really retained most of their historic buildings since their founding. Next slide. So we used the C.A.R.E tool manually. I had to build it out because the tool itself can only look at building by building at this moment. But when we apply that building by building approach to the entire campus, the first thing we did was look retrospectively to understand over the campus's whole history, how much carbon have they avoided through this stewardship approach. And what we found is that they've avoided roughly 34,000 metric tons of carbon dioxide compared to an approach that replaced buildings at the sort of renewal cycle rather than reusing them. And just to put that metric into context, they have about 100-acre arboretum campus. And if they planted their entire campus with forest, that forest would have to grow for hundreds of years in order to sequester the amount of carbon dioxide avoided through reuse. Next slide. And so that's retrospective, which is nice. But really what we want to do is help with decision making. So this is another chart that looks at the sort of their period of time that they have to get to carbon neutrality from 2007, when they committed to achieve carbon neutrality, through 2037, which is the year by which they want to be carbon neutral. And we're looking here at annual emissions, not cumulative emissions. So the top three, the light green, the red, and the gray, are essentially corresponding to the three CARE tool scenarios. The gray is do nothing, which means that your emissions are static. The red is the replace scenario. So every time a building reaches its renewal cycle, every 40 or 50 years, the building is replaced. And you can see the giant spikes in carbon emissions across the portfolio associated with that decision, as opposed to the light green, which is renew rather than replace. But what you notice is that neither the red nor the light green gets very close to zero. So that leads us to the darker green line, which is not just reusing or replacing buildings at the end of their life, but taking good care of them in the meantime, and implementing energy conservation measures like converting to LED light bulbs, like retro commissioning, like air sealing, keeping the windows and doors tight, that kind of thing. And so that approach of both reusing buildings at major renewal points and taking care of them, maintaining them, and stewarding them throughout their life is the approach that really gets us down close to zero. Next slide. And what we can see is this is now looking at the total savings achieved during this 30-year period from each of the scenarios. And we can see that if we tried to get to net zero by just replacing buildings with high performance new construction, we would basically have a wash in terms of carbon savings compared to just leaving existing buildings as they are. However, if we take that approach of reusing and upgrading, we see a savings of about 40% on the path to net zero. So that's really, kind of a huge win, and like a huge indicator that we have to really, we have to, it's an imperative to reuse and steward our existing buildings as we approach net zero. All right, back to Erin for the live demo.
Sorry, Erin, you'll have to unmute.
Sorry, thank you. All right, so what I was saying is that this is the point where we're gonna get into a little less formal talk here. So get ready to start asking questions, and I also welcome questions during the demo if anyone has questions specifically about the tool. Otherwise, I'm just going to run through it pretty quickly. So I'm going to show how easy it is. You just can go right down to caretool.org. And it is right here on the homepage. Once you get there, there are a lot of supporting resources. We are working on populating out a lot of these pages, but in particular, just so you're aware, the About section has a lot of info. There's a very detailed user guide that Lori and her colleague wrote. And then we have, again, a very, very detailed data methodology section that Lori and her colleague led writing. So there's a lot of information and support there. So I've already covered this pretty well, so I'm going to walk through it. I'm going to choose a state that I grew up in, and we put in a zip code. And so now the tool already in the back end is doing the work. It has the climate information, so I'm going to leave this alone. And for electricity grid emissions, I am going to choose a full decarbonization scenario. You know what? Since we're looking outside of the US, I'm going to do the enter your own actually, and I'm going to say our 0 year is when this grid in Colorado will decarbonize. And then this is the place where you put in how long you want to be measuring these emissions for all those charts. And so I'm going to stick with my 17 years. Then you hit continue. It automatically takes you to the next tab. You can also click between tabs, and it'll retain all of your information. So for this existing building, I'm going to put in some floor area here, some information about the number of floors above and below grade, and the type of structure that this existing building has. We'll say it has a steel and concrete structure. Window to wall ratio, I'm just going to leave that alone. It defaults. If you care to get more detailed, feel free. And then here's where we choose what the use types are for our existing building. So let's see, let's do a K through 12 school. That could be fun. And then we'll do a second use type. Okay, you can see here that that was enough information now already to get these charts populated. So they're not complete yet, but from this point forward, any additional information we add, the charts will automatically update. So what that means is that you can start playing with inputs and you can see live what the implications of those various inputs will be. I'm just going to choose a secondary use type for fun. Let's say there's a movie theater in our K through 12 school, because that sounds pretty awesome. Put in some floor area for that. And so all of that, just putting in the zip code and putting in that use type information, that was all the tool needed to tell me what it thinks my existing building energy use is and what it thinks my existing building operational emissions intensity it is. All of this, again, you can customize this, but for now I'm not going to. I'm just going to let it do its thing. Then we get to the building reuse tab, which, as Lori said, is the one that asks by far the most detailed information. So we can change, or we can say that the reuse does or does not include an addition here. If I say yes, it'll ask some more questions, but I'm going to stick with no in this case. This will also allow us to change the existing building use type at all. Again, if you say yes, it'll pop up those inputs and you can adjust them. And then here, already populated the energy and emissions. If I had made any changes up here, these would also have automatically changed. And now it wants me to set my reuse energy reduction target. And so this is essentially how much energy efficiency am I aiming for in this project. And we'll say I'm doing pretty decently. I want to get at least a 50% reduction in energy efficiency. Let's even go to 60. And it asked me if I'm going to upgrade this building to all electric equipment. Essentially, am I going to electrify? And so I'm going to say yes. I don't want there to be fossil fuel equipment in my building. And are there going to be any on-site or off-site renewables that are going to make my building even cleaner, because we're using non-fossil fuel electricity? So again, I'll say about 30% of this demand can be met by renewable energy. So that's it. That's all you need for operational emissions for the reuse scenario. And then for the embodied emissions for the reuse scenario, this is where you have to start to make some decisions about how big the impact is going to be. So the first question is, how much of the structure am I going to reinforce or replace? So if it's 0, then I just get to leave the structure fully as is. And if it's 100%, it's going to take a ton of embodied carbon, because structures very, very embodied carbon heavy typically. So I'm going to say we'll do maybe 40% reinforcement or replacement, which is actually a decent amount. Envelope reuse, a few questions about how you're going to impact the envelope. It is worth noting that for all of these sections where we think there's any potential to be confused either on how to use the tool or how to choose the correct input, we have fairly detailed information eyes that explain the purpose of this, the purpose of this slider in this case and how to make the best decision. So I'm going to say that we're doing a little bit of exterior wall work. We're going to reglaze, not fully replace our windows. We're going to do just some restoration on the roof. Don't need to insulate. Interior reuse, very similar set of sliders. How much is going to be restored? How much is going to be completely new? And how much is going to be rebuilt or reconfigured? Again, there's a little bit of information to help make the right decisions on this. I'm just going to choose some random things for the purposes here. And then MEP, I am going to say that this is a major upgrade, because I said that this building is going to be electrified, and that will typically be a major replacement. And then there's a set of modifiers. You'll see a similar thing on the new buildings tab that can make some minor but potentially important changes to some of the above inputs. So if you're using low embodied concrete, if you're using responsibly sourced timber, low embodied emissions envelope, and then high performance MEP. So I'll just choose a couple of those here. And so with that, we have our picture of our reuse and addition. We can see we're clearly already doing better than the new construction, than the do nothing. That doesn't surprise me, since I chose a significant energy efficiency improvement. And then we'll quickly go to the new building scenario. I'm gonna, like Lori showed in her example, keep this apples to apples. So I'm gonna keep the same use types here. You certainly don't need to do that though. It is still, still a great comparison, even if the use type change. I usually change them for demos. We'll do 3,000 here again. Again, it's already populated the energy and emissions for us. We will say how much energy efficiency we want for this one for new construction. The assumption is we should be able to get a decent amount more energy efficiency. Again, electrify. Again, the questions about renewables, how much procurement or generation or procurement are we going to get? We can now see it starting to populate there. And then for new construction for embodied emissions, it's significantly easier for the reuse. We can talk about the details of that, but in primarily structure is what drives the embodied emissions by and large for new construction. So in this case, we just are going to choose our structure. You can see that that blue new building line popped up dramatically when I chose that on significant amount of emissions there. And then those similar modifiers. And with that, you have all of the outputs that you could expect. And so now at this point, you either, you take a pause and we can take a pause and we can answer questions, or then, like I said, you start going back, flipping between the tabs and making some changes to see what the impacts of different outputs and different decision-making might be. So whether they're at a really high level or something like, okay, what if I am for my new building actually able to achieve a 82% energy efficiency, pretty, aggressive there, but hypothetical, and you can start to see what the updates will look like. And I'm going to pause there because I think it's a good time to dive into questions, and happy to do any more through this lens, but let's also talk big picture here.
Thanks so much, Erin and Lori. That's great. I'll ask you a few questions. I think there's some really interesting insights there from this, and I think one of the key takeaways for heritage conservation people will be that it assumes that the do nothing scenario with historic buildings is not an option. That in this scenario, to actually get solid results, there needs to be retrofitting. And I think that's one of the things that sort of sits in the background of a lot of heritage conservation discussions, is that we're already virtuous, but that idea of that heritage places need to step up and do the retrofit work as well is embedded in this tool, and it shows how the impact that can have. A couple of quick questions, and I'll flip it over to Emad and Austin to dive in with some of what they're seeing from the questions too, and some of their insights generally. There's a number of questions in the coming in about energy sources, and how do you identify energy use in a particular area? How did you go about doing that? Or just, I'm thinking about how to some of the challenges around updating this tool and calibrating it to the Canadian context and what that's going to take. I don't know whether you wanted to dive in, both of you, on that and on the climatic conditions and how that gets embedded in there as well.
I mean, from an operational energy perspective, emissions perspective, that's actually a really easy answer. I think it's maybe potentially more complicated from embodied carbon. From operational emissions, the way the tool works is that it is using an API, it doesn't matter if you know what that means or not, to connect to Architecture 2030 Zero tool. And the Zero tool is the pretty just kind of like industry standard energy and emissions baseline and target setting tool. And Canada has already built into the Zero tool. It's based on EPA's Target Finder and Portfolio Manager, which has Canadian building energy consumption survey backend data that is comparable to the US backend data set that powers the tool. And so all we really need to do for operational emissions is find the funding support. We're currently in another fundraising round to do all of our next plans for the tool. We need to find the fundraising support to just implement that connection, and then you will be able to do the exact same thing, but go in and choose Canada as your country. Then you'll be able to choose your province and put in your post-upload, et cetera, et cetera. So aside from money, that's an easy win.
Emad or Austin, did you want to dive in? I'll bring up some other questions as well too.
I guess I can dive in first, but it was very similar to first of all, thanks Erin and Lori for this. This tool was kind of long overdue, but coming back to the energy consumption to use to populate, I think, the tool. There were similar questions also in the chat about like, for example, if you have an existing building, and say, for example, I'm an architect and I want to prove to a client that it's a better deal to keep the building and retrofit it as opposed to replacing it with new. That's probably going to be bigger. That's probably going to be more denser. So so how do I know, for example, what kind of data to use for an existing building that's probably an existing office building? Is there a way, like, can we ask like their energy bill? I mean, this is kind of tough to sometimes ask questions for that, but and how does that relate to, for example, the embodied data that you have in there that relates to the energy grid or the electricity grid? I'm not a mechanical engineer who knows all that stuff, and I'm not very much a data person. So I'm just wondering how do I justify to a client that this was the right numbers to use so that they can see that there was credibility in there.
Yeah, I think that's a great question. I can answer it from an operational perspective, and I might let Lori take it from an embodied carbon perspective. But the short answer is yes. When you're entering the operational energy and emissions info, when I did the demo, I just did the default where it does the connection to the zero tool. In fact, there's more information about that here, pulls from that and auto generates it, but you can enter your own. So if you have an energy model, or if you're the architect or engineer, or someone has an energy model with an energy use intensity, you can enter that. Or like you said, if it's an existing building, there's going to be utility data somewhere for that building. And so you can enter the utility data, add as many energy sources and types as you want, including renewable sources, and get a very, very precise and accurate energy use intensity. And the operational, or I mean, the emissions assumptions are based on the electricity grid, obviously. And so currently the tool looks at electricity grids throughout the US at a semi-granular level. And if we connected it to Canada, we would have to find comparable electricity grid information. But again, you can also, you can kind of work on manually customizing that. And then the emissions from fossil fuels have standard emissions factors that are just the nature of the fossil fuel. So those don't change from the region to region.
Austin, did you want to jump in?
Sure. I thank you, Lori and Erin. It's very helpful. First, one general comment. I'm glad in terms of the slide of the local reduction in carbon emissions. When you say 41% by working on buildings, it reminds me an ounce of prevention is worth a pound of cure. I just wanted to put that out there. One thing I did want to say is when I look at this C.A.R.E tool, as you said, I know it analyzes a specific type of problem, and it's looking at the embodied carbon cost of making existing building energy efficient. And it's not an LCA tool, as you said. And it's interesting that you don't deal with the demolition of the where you take out the materials, and you don't deal with storage at all, in terms of you're looking at the existing building from a retaining carbon point of view. That's really kind of interesting, given that when we deal with these carbon cycles, we're always trying to think about storage and what to do with that carbon. But it's also really a question about retrofitting or replacing. And as I say, it's a great gateway tool. I saw it when I looked at it. I looked at it at a very high grain. And if I didn't know what an EUI was, which is energy use intensity, which is amount of energy per unit area per unit time, or if I didn't know what a degree day was, I didn't know what decarbonization was. And I know I saw this in the chat. Those of us in Nova Scotia were still burning coal to generate electricity, and hopefully we'll decarbonize by 2030, but we'll see if that happens. So, I mean, there are all these interesting ideas and comments which are very apropos to operating energy and embodied carbon, operating carbon and embodied carbon. So it's a very good way to introduce the subject. Also, you bring out really interesting assumptions. Your results are based on a level of energy efficiency and a timeline. And I can get any result I want depending on what level of energy efficiency or timeline I pick. The farther I take the timeline out, the more important operating energy is, the closer it is, the more important embodied carbon is. We know that. We also, as I mentioned to you guys before, when I was playing with it on the weekend, I picked, what EUI do I use? There's a question out there, and that's really that's open. What I did was I said, because this is one of my pet peeve problems. I see a lot of the heritage buildings in Halifax, and typically people they want to make them more energy efficient. And the first thing they do is they do a deep retrofit. So they take out the envelope, they take out the windows, they take out the doors, they replace the roof. What's left is the structure and sheathing. and then they try and make it more energy efficient. So I said the first scenario I wanted to look at was inner house standards. So sorry, passive house standards. So I looked at for new construction passive house, and for old construction I looked at the inner fit, which is the passive house standard for renovation for renovated buildings. In that instance, with a 25-year time frame, it was more. It had less total emissions for the new build than I did for the retrofit. And so that told me, then why bother doing a retrofit, that extensive a retrofit? Because if you're removing these elements, ideally you want to do it to make the building more energy efficient. From a carbon point of view, it just means make a new building. And I'm not suggesting to do that. I'm just saying that was an interesting high-level decision. The next thing I said was, okay, I don't want to do that. I want to retain as much heritage value as possible with the building, because there is a difference between, as we talked about, heritage and existing buildings. And what I came up with from experience is that you put a 30–40% cap on in terms of how much more efficient you want to make the building, you can retain your your character defining elements. And once you get beyond that point, you have to start losing them. So when you do that and you compare that to a new build, it's much more efficient, or you have a lower carbon intensity to keep the existing building. So what I found very interesting about that is if one wants to retain the heritage value in a building and is prepared to compromise for some middle ground in terms of energy efficiency, the model does say that it's much more, in terms of reducing carbon load, it's much better to keep the building than to build a new one. So I thought that was, just put that out there. That's the way I use this tool, or I use the tool as just to get a first order back of the envelope analysis of what I should do, what I shouldn't do, and how far I can take that energy bar before I start chipping away at the heritage value of the building. Very interesting. So I wanted to thank you for that, because it very clearly told me a defendable, quote unquote, defendable strategy, because ultimately it comes down to what, so assumptions I make that can be challenged in terms of those timeline issues. So I just wanted to throw that out there as a point of conversation, but that's how I use the tool. And I realize there are all kinds of issues in terms of clarity of data and consistency of data, but for where we are now, this tool is the only one that does that. So thanks.
I had something I can ask too, and there seems to be some chats in there too. But understanding that the C.A.R.E tool is meant to be a very high level, intuitive. But when we select, for example, an existing building that's either wood or steel or hybrid, what's the default in terms of the materials to understand that? Because, for example, like a wood building from the 1860s is very different than a wood building from the 1970s. Same thing for masonry, whether it's stone or brick. So what's the default that's considered when we choose a material? And what's kind of like the not the premium, but like the difference that we need to take into account when we analyze the data and interpret it?
Yeah. So when you select the structural system of the existing building, it's not quantifying the embodied carbon of the historic materials. It's using that information to kind of guess at the embodied carbon of a structural retrofit made to that historic structural system. So so while those typologies might be very different, it's kind of more trying to categorize how we intervene with them. So for example, if it's a wood, completely wood structure, then you might be able to upgrade that structure just using wood. So if you needed to sister joists or add posts or something, you would probably use wood structure. So it's going to have a low embodied carbon. If you have a hybrid, which there's some commentary about this in the user manual, that does include like a masonry structure with heavy timber framing, for example. That might be, that structure, if you're going to intervene in it, might use some combination of steel and wood, if you have to do seismic upgrades, for example. So that's a little bit heavier. And then the heavy structure, concrete or steel, assumes that you're going to have to use concrete and steel to make those structural upgrades. So I hope that helps clarify that it's not necessarily about capturing the specifics of the historic structural type.
I think so too. And if I may think about it, if there is a difference between one to the other, I hate to say this, but it may be a cost difference. That's where like we as architects, like if it's a very old wood versus a very new wood, the materials to restore it from a historical conservation perspective may be more of a costing than an operational or carbon. So yeah, I think it's the unfortunate thing we know, but yeah. So
yeah, it's interesting. Building on that, Emad, there was a question earlier on about cost in the results, and I think that I would throw that to Erin and Laurie. I mean, what level of new data would we need to add that into the results side, so you could really go to you could really get a sense of the order of magnitude on the economic side about the impacts here. I think it would be pretty fine grained and quite regional in some ways as well too.
I mean, yeah, short answer is you're absolutely correct. It would be very fine grained and regional by necessity to be accurate. That is certainly not the first time we've had the ask of, you know, what does this look like from a cost perspective, or is that a metric that could be wrapped into the C.A.R.E tool? Also interested in metrics beyond cost and carbon. For the record, we get a lot of questions too about equity and you know, just transition, kind of all the other metrics that float around the climate conversations and the preservation conversations. I would love to incorporate cost data, and from work I've done for other projects with Architecture 2030, it is very, very challenging because it is so market specific and region specific. Even within a state in the US, it would vary dramatically between, you know, a metropolitan area versus a more urban area, much less the entire country, much less the entire world. So I'm not 100% sure how to say what that would take. It would be great and it would be a challenge.
Another question I'd like to jump in, because I know we're running down in terms of our time today, but in terms of the policy and the implementation kind of dimension, how can we embed, like, what's the vision? What would be the vision, the dream vision, I guess, for the two of you, in terms of how this could be integrated in a kind of instrumental way at the kind of the governmental policy level to really give it legs? Do you have some thoughts on where this could go?
Yeah, Laurie, you want to answer that? We talk about this a lot.
Yeah, I have so many thoughts. I think my ideal involves C.A.R.E in so many ways. I think, you know, one way is when it comes to zoning and permitting of construction projects, that this would allow, it would allow projects to be responsible, not just for reducing their energy and their operational emissions, but for thinking about the total carbon, the sort of total environmental impact of a parcel or a neighborhood or a city, and really, you know, kind of essentially getting a credit for reusing an existing building because you're reducing the embodied carbon up front when it's so critical. So I think that, you know, that's one way that I think it could be really useful. I also am interested in how the tool can be used to tie heritage policies into climate policies. For example, we've had like in the United States, state historic preservation officers who are interested in quantifying the avoided carbon of the historic tax credit programs, so that you could kind of, you know, use that as a way to make the historic tax credits part of energy tax credits or climate credits or just, you know, climate policy and regulation in general. So those are two from my wish list.
And just so you all are aware, one of our big next goals for the C.A.R.E tool is to create C.A.R.E for portfolios. So the example Laurie gave of the Agnes Scott campus, where she did that manually, we want to create a tool where you can upload information about an entire portfolio of buildings at a campus level, you know, heritage portfolio owner level, real estate level, even city scale. So our goal would be for some of those policy considerations and questions to be able to be really part of the planning and policy making discussions at, you know, those very early levels before we're getting to the point where buildings are even being touched.
So really quickly then, just to recap around the Canadian context and trying to, you know, develop this or to enhance it for the Canadian context as well, we would need embodied carbon data by region. We'd also, like, maybe that some of that is overlapping with American data. We need the climate data. We'd also need the electrical grid options to be added in. So would those be the principal areas, the principal buckets of data we would need to really scale us up in the Canadian context?
Yeah, they would be. And like I said, I think from an operational perspective, it's pretty simple, although the electricity grid emissions data could be complicated. Laurie, you can talk about embodied carbon. We've talked about this. I'm not sure how dramatically different the embodied carbon assumptions will be between the US and Canada.
Yeah, I think there are some, you know, inherent assumptions baked into the tool. For example, if you click the checkbox to insulate walls, it assumes a sort of US average, how much insulation would you need to meet code? So if we're starting to go into other parts of the world, there are some assumptions that we might want to reevaluate to make sure that the way we're allowing users to define their building reuse is applicable to the buildings the building typologies, the stock, and the way you reuse buildings in that area.
Chris, I'll just say one simple, for people who most people probably know this, but if you go to a website called climatedata.ca, you're able to get climate data based on up to 2100. So you'll be able to see how the climate in your area is changing, and it gives you heating and cooling degree days to do that. So that's helpful.
That's great. Okay, well, I think we're going to have to leave it there. I want to thank our, I think people can circle back with you, Erin, with any other questions.
Both of us, actually. Yeah, I'll put my, I mean, we might have lost some folks, but I will put my name, my email address in the chat. Lori can as well, but we also have on caretool.org, there's a feedback button right at the top, and we welcome any feedback, not only, oh, this doesn't seem to be working, or have you all thought about doing this, or I don't understand how to do this. So that sends an email to everybody on the CARE team. So you're welcome to do that way too.
It's come such a long way from when I first saw it piloted at the 2020 APT National Trust for Canada and CAHP conference. I mean, anyway, when it was a very kind of nascent stage. This is amazing. Thank you so much to you, Erin, and Lori, and to Emad and Austin for joining us today. Emily, do you want to flip up that one second last slide? Actually, maybe go to the next one. I just wanted to flag just before we trail off. The National Trust has undertaken this Heritage is Climate Action Initiative. It's an ongoing initiative looking at things like climate mitigation boot camps and green audits. So stay tuned for more information there. Thank you so much to our guests, our presenters, and to CAHP for co-presenting this webinar with us. I'm looking forward to unpacking some more of these questions over the coming days. But thank you to all for your participation.
Thank you.